Surface area and volume of pyramids and cones. Before we can begin to solve for both surface area and volume, we need to understand the difference between the two shapes as well as the difference between surface area and volume. So this over here on the left is a pyramid. This over here on the right is a cone. The difference is that a pyramid is made up of 4 triangles and a square base. A cone has a circular base and has a smooth edge, okay, that goes up to a point. Surface area is the sum of the area of all the sides of a 3D shape, and this will be measured in your units squared. So if we take a regular 2D shape, a triangle for example, the area is how much space that shape takes up. For surface area, these 3D shapes have multiple sides that makes it 3D. So for our pyramid, it is the area of those 4 triangles that make up the body of the pyramid, as well as that square base is your surface area. For the cone, it is that circle base on the bottom, as well as this almost semicircle-like shape you can see it's folding out into, that would make up the surface area. You can think of surface area as like wrapping paper, for example. If you're trying to wrap a pyramid, how much wrapping paper would you need? Or if you're trying to wrap a cone, how much paper would you need? Volume, on the other hand, is the amount of space inside a 3D shape, and this will be measured in your units cubed. So if you were to fill up this pyramid with sand or water, how much could it hold? Or if you're trying to fill up a cone with maybe some, I don't know, like an icy, a slushy, like a snow cone, how much of that snow cone treat would you get in your cone? Okay, so the inside is the volume, the outside is the surface area. Okay, to begin to solve, you are given the formula sheet on any test. We're going to start with a pyramid. We have a pyramid here, and this picture on the right is the formula sheet. V stands for volume. So the volume formula for a pyramid is 1/3 times the base, the area of the base, times the height. Surface area is 1/2 times L. L is your slant. P, the perimeter, plus the area of the base. Okay, so let's make sure that we understand each part of this formula. This capital B, this base, is referring to this square bottom, okay, and the area of this square bottom. So if it says maybe it's 6 wide and 5 deep, B would be 30. So the area of that square or rectangular base. Okay. H is your height. That is the height that goes straight up, which is different than your slant height. So we're talking about this height right here from the point straight to the bottom, like that. This L is your slant height, which is this height. If you were to stand at the top of that pyramid and slide down the edge there, that is your slant height. So that's going to be a different measurement than your height. Okay. Also in this picture, I want you to see that if you're missing your slant height or your height, this creates a right triangle. Your height with the slant, and then half of the distance going all the way across, half of your length of your pyramid would be this last leg. So if you're missing one of those, you can figure it out using Pythagorean theorem. A squared plus b squared equals c squared. Okay, so now let's look at a practice problem. Oh, I'm going to skip here, and then we'll go to cone next. So we have this pyramid. It's 10 centimeters wide, 4 centimeters deep. We have the slant height, 13 centimeters. This is an example where we are missing that height. Okay, so to be able to solve for your volume, this is the volume formula right here, you need that height. To calculate the height, I'm going to draw my right triangle here. We're going to use Pythagorean theorem, which is a squared plus b squared equals c squared. C is always that hypotenuse. In this case, c is going to be 13 centimeters. We can say that this is a and this is b. B is going to be half of that length, so don't use 10. B in this case is 5. So once we plug this, we can plug our values into this Pythagorean theorem equation here. A squared plus b squared, 5 squared is 25, equals c squared. C squared, 13 times 13 is 169. We can subtract 25 and take the square root, and you end up with 12. Okay, so that's how you figure out your height or your slant. Maybe you're missing your slant. You need to do the same thing. Use Pythagorean theorem. So once you have all of your variables, you can see this is what you're going to plug into Desmos. You do get Desmos for any surface area and volume questions you might have, as well as the formula sheet. So you don't have to memorize these. You just need to memorize actually, you don't have to memorize what these variables mean either. Your formula sheet will tell you. So here I put in the volume formula again, a half capital B H. I put in the surface area formula, and you can see that I don't write V equals SA equals. I only put in the formulas. And when you put in these formulas, initially you're going to get this little warning symbol until you tell Desmos all of these values that it needs. It needs these 4 numbers. So to solve for volume or surface area, you need a total of 4 different variables. You need to know your area of the base, which is your length times width. 10 times 4 is 40. You need to know your slant height. Sometimes that's given, sometimes it's not. Your perimeter, okay, you're going to, the perimeter of the base, that's 10 plus 4 plus 10 plus 4. And then your height. Again, sometimes it's given, sometimes you have to solve for it. But once you plug in all 4 of those values in, you will have your answer for both volume and surface area. Okay, going back to cone now. This is a cone. A cone has 1 less variable to worry about. A cone, you have your height, your radius, and your slant height. Now, sometimes depending on the picture, depending on the question, you might be given the entire length of the cone. But know that the radius, okay, is going to be half of your diameter. So this total length is your diameter. We only want radius for our equations. You can see the R is used in our equations, not diameter. Now, I have this one highlighted. We're going to use this top formula, or we practice using this top formula in class. You could also use this second volume formula, a third times the area of the circle times the height. But we determined that this one's going to be a little bit more work. You then have to go find the area of a circle formula, calculate the area of the circle to be your capital B. If we use this formula, we can use pi radius squared, which is essentially the same thing. We're just going to plug it all in to our line on the calculator instead of figuring out what the area is and then plugging it into B. These two will both give you the volume, but we practice using the top one. Okay, so again, surface area on the bottom, pi radius squared plus pi radius slant. Okay, so now let's practice this one. And I'll go back to this problem. That picture, I forgot to show you that one. Okay, so here's an example. We have our height is 8, our slant is 10. They gave us the diameter going all the way across, so I know my radius is half of that, which is 6. And then this picture actually does a good job of showing you this triangle, this right triangle right there. So this is another case where you can use Pythagorean theorem if you're missing either your L, the slant, or your H, the height. I put in the formulas for volume and then surface area. And then, like I said earlier, cones only have 3 variables that you need to worry about: your height, slant height, and your radius. And once you plug in all those, you will get the answer to your volume and your surface area, which, interestingly enough, for this one, they're equal. Okay, I'm going to go back to this question right here, or this picture right here. I forgot to show you this. I thought this was a really good drawing for you to see that right triangle inside a pyramid. Okay, so this is why we can use Pythagorean theorem to solve for our slant or our height. Okay, and that is surface area and volume of pyramids and cones.